Hi friends, welcome once again. Friends, we are going to pick up a very important technique of demand forecasting, that is exponential smoothing. In the previous videos, we have seen what is moving average. Remember friends, whenever we are doing this moving average or exponential smoothing, our idea is to smooth the trend, to do the smoothing of the trend. Now the question is why it is so, because as I already explained you, the time series data has got a long range of data and there can be some fluctuations in between, as a result of which we are not able to know the underlying trend. In order to know the underlying trend, we need to smoothen the data. Now, one way to smoothen the data is by, giving lesser weightage to the old data and giving more weightage to the new data. Right? So in a time series, you have old data and new data. So you are going to weight lower for the old data and more for the new data. You do the same thing under exponential smoothing also, but you are doing the weightaging or giving the value to the old data is been given or as you go as you go back, or in other words, the data which are relatively older, it will have lesser value and this value will reduce exponentially. Okay, you are assigning lower values to the older data, and this giving lesser value to the older data will be done in an exponential manner. So now, for friends, leaving aside the theories which are important, how to operationalize this technique? For this, you have FT. FT means forecast. Forecasted value is equals to alpha times YT minus 1 plus 1 minus alpha times FT minus 1. What does this mean? This means if you want to forecast a value of a variable, you first have to find out what is alpha. Alpha is a smoothing factor, and this smoothing factor varies between 0 to 1. It can be 0.3, 0.5, 0.7 accordingly. YT minus 1 is the previous period's actual value. So suppose you have this 5 years data and you want to predict the 25th year's actual data, forecasted data, 2025, the forecasted value, then your YT minus 1 will be 140, means what is the actual sales data of the previous period. So actual value of the variable at the previous period, because YT minus 1 means 1 year or one time period back. 1 minus alpha means if alpha is 0.3, so 1 minus alpha will be 0.7. FT minus 1, what is the forecasted value of the previous period? Okay, so let's do a problem and let's see how to compute this forecasted value. So for this, we have 5 years data and you have the actual sales value here. Okay, so actual sales value given, we have to find out the forecasted value, and this forecasted value for the first period will be as it is 100, so it will be 100 only, and then we will go on forecasting the second period, third period, fourth period, fifth period, sixth period, like this. How to do this? We will write in the equation the values. Let's assume that the smoothing constant alpha is 0.3, so I'm writing 0.3. YT minus 1, we are forecasting for the second period. So what is the actual sales value of the previous period? 100. So I'm writing here 100. 0.7 means 1 minus 0.3 is 0.7, and the forecasted value of the previous period, that is 100. So we have written here and we got 100 as the forecasted value of the second period. Similarly, you do for second, third, fourth, this way. And if you want to know the 6th year's value, 6th year's forecasted value, 0.3 into previous year's actual value, 140, plus 0.7 into previous year's forecasted value, 116.5554. So you are expecting a forecast of 123.58. Means in the coming year 2025, the forecast is forecasted value is 123.58 of a product. Done. Now the question is, how far is my forecasting correct? We also have to parallelly see that the forecasting are accurate. You know, forecasting cannot be exactly same or exactly accurate, but we are expecting that we are around the actual. So that's why we want to see that the error is less. Forecasting error is less. When will be the error? Error will be when there is a difference between what has happened actually and what you have forecasted. So in order to minimize this error, we are trying to see whether things are fine or not. Maybe the constant is chosen wrong. We have chosen with 0.3, but maybe the constant was supposed to be 0.7. How can we judge this? We can judge this with the help of two measures. One is this one, mean squared error. Mean square error is nothing. Your y means the actual value minus f is the forecasted value. You sum the difference and square it. So for example, my actual and forecast, there is no difference, so 0. Actual and forecast, there is a difference of 20, so you square it, so it becomes 400. These two minus, square it, this much, minus these two, then square it this much, and then sum them all, it comes to this much. After summing, you have to divide by the number of time periods, which is equals to 5. So ultimately, you get the mean square error is 333.12. Now, whether it is correct or not, you can do one thing. You can start, if this is lower the MSE, better it is. As you can understand, obviously, if the error is less, it is much better. So you can do one thing. You can check it with a smoothing constant of some other factor, 0.7 or whatever, and check whether the value is lower or not. If the value is lower, then you can say that this computation is required to be revised with a new smoothing constant. But there is another measure, we call it RMSE, that is the root mean squared error. Now what does this mean? You just take the root of this, square root of this. Square root of this will tell us the degree to which your forecasted value may not become true, the degree to which there is a variation between the actual and forecasted. Here you are talking about the absolute value, but RMSE will tell you the relative, or in other words, the percentage of variation between the actual and the forecasted. So I have calculated, it comes to 18%. So there is a chance that there is 18% variation of your forecasted value, that is 123.58 may go up by 18% or down by 18%. So friends, this is all about exponential smoothing. So we are talking about all the techniques, quantitative techniques of demand forecasting. See you again with another new video. Bye-bye.